I have a quick question if I could ask.
Yeah, go for it.
So in plotting the course, I was doing some of the homework assignments. I have the parallel rulers.
Mm-hmm.
It works fine if the course is if I can measure it with the length of my ruler. But when we started doing ones where it was almost entirely across the map,
Yeah.
the best I could kind of come up with some kind of trial and error with a lot of stray lines. I couldn't figure out how to do it, and I looked in the book and didn't find any good tricks. I guess I could come up with a few ideas of find some other straight edge that's long enough to draw your line.
Yes. So also check out my homework tutorial videos. I kind of showed a couple different ways. You know, if you have a yardstick, that's great. But like putting together two or three different straight edges to try to extend the line is the most reasonable, I guess. But also, if you know you're going to be crossing long distances, it's always good to, in my chart tube, I have a yardstick just because it's in the chart tube, which makes it easier. But yes, on the extending out, you just kind of extend out a line as far as possible, really.
Yeah.
But yeah, we had a couple of big long ones across the sound there.
So the answer is really you need to come up with a straight edge long enough to connect your dots.
Yes. So let's see, I can show you on here. So I have my camera low right now, but yes, you kind of just extend out as far as you can using different straight edges. So if you have a ruler, you have the parallel ruler, whatever you can do to get it stretched out as far as possible. Or you can, you know, create a waypoint just somewhere in the middle and say, I'm going to go there, and then I'm going to go there. Create a little dog leg. But yeah. Yeah, some people, I always find some creative people on those questions. Using like big old, like the metal measuring tapes. Or yeah, all sorts of different things. So yeah. All right, we got a couple people on. Any other questions from the group? You guys masters at latitude and longitude, course and distance now? Getting there? All right.
So plotting the course, it's always degrees off of true north, right?
Correct.
So that's when we're left of true north. That's when we're going to have like 330 or getting close to 360, and then right, we're going to start at 0. Okay.
Yes, yes. So everything on the chart is true. So when we read it from the chart or we put it on the chart, it has to be in true. Where on our boats, they're going to be most likely magnetic compasses. So we're going to talk about today about how to do that transition. But yeah, it's different than your classic algebra course where 0 is kind of pointing east. For us, 0 is always north. And then we have our 360 degrees that goes around.
Got it.
Yep. Any other questions out there?
Hi, Bree, this is Michael. I have maybe a quick question for you. With regards to the position, distance, and direction, is there any tips or tricks that you could suggest with working with the parallel rules when you're trying to cover a large span or a large distance and there's not enough space and you don't have a yardstick with you to accurately line up the points in between?
Yes, Greg was just asking that as well.
Oh, okay.
You really just have to get some sort of other straight edge. It could just be, you know, your dollar ruler to extend your line out.
Okay.
And then you find it that way. I did talk about it on that homework tutorial. I did it a couple different ways.
Yep. I just didn't know if that was appropriate or not, especially even trying to go for your Coast Guard exam if you brought in all of these extra tools and
No, the nav tools, you know, basic 2, maybe 3 triangles is pretty typical.
Okay.
And then I always have a ruler, and I use the 18-inch ruler. But yeah, that's totally fine.
Okay. Because I was also just thinking if I ever had to, work on adjusting a course, I know how it is sometimes being below and on a sailboat, 15 degrees heel and rolling seas. It's not the easiest to.
No, so doing a longer course line across a chart with multiple nav tools is challenging. So I always like to say I have it in my chart tube, a yardstick. You know, you can get a yardstick real cheap.
Right.
Just to keep it in the chart tube because it's the same size, and then you have a long.
Yeah, that makes perfectly good sense. I just didn't know if you could use it. So
Yeah.
Okay. Thanks.
Yeah. Any other questions out there? How are we doing today?
I had a question.
Yeah, go ahead, Shelley.
Hi. On the assignment 4, number 4, I just wanted to see if 259 degrees and the distance 26 is correct or close. On number 4, assignment 4, position, distance, and direction, number 4, 259 degrees and the distance 26. Because we had to kind of we only had one triangle, and then we got the ruler out. My husband, I just ordered the plotter type ruler is coming.
Okay, so yes, assignment 4. If you got 26, that's fine. I got 25.5.
Okay, and
so yeah, within a half mile is totally fine. And then for the direction, what did you get?
259.
259. That is, I'm gonna say pretty far off. I got 280, so you're about 20 degrees off on that one.
Oh, wow. I wonder. Okay.
I would definitely check out when you come across a question like this. Check out those videos, the tutorial videos, because I do go step by step on each question.
Okay. Thanks.
Yeah.
I did do the videos a little.
Okay. Cool.
Thanks.
Cool. Any other questions?
Where are the videos?
They're on YouTube. There are also a link to them on the Google Classroom. Here, I will bring that up here. Okay. Uh-oh.
So under stream.
I guess I'll share this. Okay. Can you guys see my Google page here? Yeah?
Yeah.
Okay. So for under classwork, under assignments, view more. I put all the assignments on today. So we have answers to the assignments, so you could check your answers. And then we have video tutorials. So for assignment 4, you could click on the video tutorial. Oh, it doesn't bring you to, I wonder if it'll bring you watch on YouTube.
Yeah, it defaults to embedding, and then if you click on it, it'll take you to the main website.
So on pause this. On YouTube, if you click on mine and you go to the playlists for CoNav1, that's where you'll see all of the videos I've posted for CoNav1. Okay. I like to say okay a lot. I know that's one of my little tics. You
It's
learn
okay.
those things when you start videotaping yourself.
So I don't see where it says answers. So mine doesn't look.
Are you on assignments?
Under classroom, classwork,
Mm-hmm.
assignments.
And then scroll down and there's probably like a view more after
Oh.
the number 10.
Got it. Yeah. Okay.
Okay. All right, any other questions? Are we all masters at Latin long and course and distance now? Right, we're gonna move on from here and gonna get even more complicated. Cool. Okay. Well, let's dive into it. Today, hold on, having some technical difficulties. Okay. Okay. So Zoom, share screen. Okay, so today we are going to be talking about compass corrections and compass error. And then at the end, we're going to throw in a little bit about relative bearings and plotting these compass bearings as LOPs and what that means to us. But we're really focusing on compass error and compass correction. Now, before I dive into this, I think it was my last class I had this question on the Martha's Vineyard, the chart that we've been using. This is a picture of the latest version of the 1210 TR, which isn't even 1210 TR now, but covers the same area. And you can see how much it's changed over the last, what is it, done in 85, something like that. So as you can see, this training chart is only for training purposes. And it is not, it's only for training for Coast Guard exams, basically. So that's just my little caveat there. Okay, so now that we're masters of latitude and longitude, we're gonna dive into compasses. So when we think about compasses, we're basing this off of direction. And direction, so on our charts, we're always going to have the top of the chart being north. Bottom of the chart is going to be south, right side east, left side west. And then we have all of the degrees in between. We have northeast, southeast, southwest, northwest, and all the other ones in between those. So we're going to put a number value on that. So our 0 or 360, there isn't actually a 360, it goes back to 0, is north. So that everything is measured from north. So we're always basing our 0 line at the top of the chart. And then we go clockwise as our numbers increase. So northeast, 045, east, 090, southeast, 135, et cetera, all the way around. So when we see a number, we can generally say, think in our head, oh, that would be, you know, southwest. It's in the lower 200s. So it's going to be in between south and west. It's going to be in that quadrant. So it's good to when you see that number, are you in the correct quadrant? And that helps you not get mixed up on the reciprocals and those types of things. So we're going to assign numbers to these directions, these compass directions. Does that make sense so far? Okay, so this is our modern compass. We have 0 to 360 degrees. So let me, sorry. So we have 360 degrees. Again, we have our east, south, west numbers. But as you can see on our compass rose, this is the image of the compass rose on the chart. They're very, very close together. So it does give you that accuracy that we're looking for. So we want to be within, I would say, about 3 degrees. But again, the longer your line, that the 3 degrees can get more and more dangerous. The longer the line, if you're off by 3 or 4 or 5 degrees. So again, this is just a picture of how our numbering system works. On our compass, these are 2 different types of compasses, but we have a compass repeater where that compass rose is kind of flat on the repeater there. Or you have that bubble compass that a lot of recreational boats have. So when we think about the compass card and the lubber line, so the compass card is literally that little white disc there, or the black disc inside that little bubble, if you will. So that disc or that unit, yeah, looks like a hockey puck, kind of, I guess, on this one, but flat disc on that one, is always pointing north. So that N, or that 000, is always going to be pointed north. The lubber line is the one that moves around the compass. And that lubber line is in line with your vessel. So when you're watching it and you're on the vessel moving, it looks like the compass is turning, but it's really your ship or your vessel that is turning around that compass card or that little hockey puck in there. So that little disc is always pointing north, and then the boat is moving around that compass. And that's where we get, and that's how we follow the lubber line. The lubber line is in line with our center line. So it's pointing to where we're headed. Does that make sense? Okay. Okay, so that's our compass card and our lubber line. This is another picture that you might see on recreational boats. So there's that big lubber line, and we are moving around that lubber line, or we're moving around that compass. The lubber line stays with the vessel. We're moving around that compass. Okay. Okay, different types of compasses. So 3 main different types of compasses. We have a gyro compass. That's what this right here looks like. And then you have the gyro repeaters. So that's what you're going to see in the commercial industrial world on big ships. are your gyro compasses, and they need a power source. But other than that, they stay very steady and reliable. So they do need a power source, but they are very, very close to true. But if you lose power and you don't have a backup system, you wouldn't have the compass. Then you have your magnetic compass. This is a binnacle, is what it's called. So it's a magnetic compass on a large vessel, and you can use these magnetic balls, and then there's magnetic bars inside this to adjust the magnetic pull that your vessel is giving to that compass. And it's usually always very close to the top, usually on the fly bridge is what I call it, but it's high up. And then you could see here is this kind of little submarine mirror action thing. And this is just a way how to read that compass from below, is you have this little, I'd like to say submarine, but it's not a submarine thing. It's
Periscope.
Periscope. Yes. So that's typically what you'll see on a big boat. Now you guys as recreational boaters will most likely come in contact with compasses that are magnetic compasses like this, the bubble compass, or a satellite compass. So you'll have some sort of satellite receiver that's measuring, and then you'll have a display that is giving to you what the satellite compass is reading. So typically those are the two that you guys will come in contact with, but the other one out there is the gyro. And of course your magnetic, or the typical recreational compass, magnetic compass, doesn't have the adjustments that you can adjust for deviation along the way that your standard binnacle has on larger vessels.
And what does the gyro compass use to maintain the northing accurately?
What was the question?
What does the gyro compass use to maintain the stable direction?
So inside this big old thing is, I wish I could get a picture of it. It's like the electromagnetic field spinning around and around. So it's kind of creating its own north. And that's what it's moving around. Let's see.
Does it lose its accuracy the longer it's used away from some sort of source of calibration?
So with that, you can calibrate it to different latitudes that you are at. So if you are changing in latitude significantly, then you would want to adjust your, there's literally latitude adjustment on the compass, on the gyro compass.
Okay.
And usually they're like in the closet somewhere, so they don't get like bumped or damaged at all. And then you have the repeaters that are on different places on the navigational bridge or on the bridge wings or on the stern or wherever they are. And so we're going to talk about how we can measure today what true is versus what your compass is. So no matter what you're using here, your gyro, your magnetic, your satellite, you're always going to have some sort of compass error. So compass error is the difference between the actual true heading or the true bearing versus what your compass is reading. Whether that compass be magnetic, gyro, satellite, whatever it is, there will most likely be a minimal difference, sometimes large, and calculating that compass error is important in case you lose power, mainly for our satellite and our gyros. If we lose power at some point, then we're relying on the magnetic compass, which we already want to know what that compass error is so that we can navigate on the charts. So, okay. So back in the day, so that was a modern history lesson. Now we're going to go back to ancient times of history lessons. So I want to say it was the Vikings, used a almost like a bowl of water with a floating leaf and a lead rock, and that lead rock would always point to north. So if you can imagine navigating by a leaf and a bowl and a lead rock, the accuracy is way, 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 way low. So as magnetic compasses were invented and our navigation systems got more and more, our accuracy got tighter and tighter and tighter. So before digitalized compasses, meaning that number system 0 to 360, we used cardinal points. So that's your north, northeast, southwest, how you say your directions by cardinal points. And so there are actually 32 cardinal points. So we have them all here. We have north, north by east, north, northeast, northeast by north, et cetera, et cetera. But those point systems are not exactly degrees. So then we got into a little more modern sailing. We divided the compass into 360 degrees, and we realized that each little direction that we had been sailing by was 11.25 degrees. So on some instruments like the triangle, these lines on the inside of the triangle are points. So they won't line up exactly. Some of them will because it's 11.25. So every fourth little line will line up with one of these lines. But as you are coming across, so this is just kind of a little history lesson here. As you're coming across this, you will see that point system, which is 32 points, and then the degree system, which is 360 degrees. We go by the tight accuracy of 360 degrees because we think we can maintain a course within 1 degree, sometimes even a 1/10 of a degree, depending on what type of vessel you're on. So that's how accurate we can be. Okay, this was just a pretty picture of the old compasses. Okay, so when I say point system, I had the 32 point system. There is also another point system that I don't want to get confused on. I was taking this slide out because it's excessive and extra fun fact for you. But when we talk about relative variance, which we're going to talk about today, it has to do with kind of this system. So I'll talk about it. Anyways, so your lookout point system talks about how if you were to see a buoy or something off your boat, how do you communicate that to another person on board? I think the most common for recreational boaters is to use that clock system that says, oh, it's at 3 o'clock or it's at 2:30 or something like that. Use a clock system that kind of represents the bow of the boat at noon or 12, the stern of the boat at 6, and kind of where things are. That's not an actual official maritime way of directing where something is. Our official direction way is using this point system. So we have 4 basic point systems. We have dead ahead, and then you have a beam. So you have starboard beam, port beam, and then you have broad on the starboard bow, which would be kind of that 45. So right in between dead ahead and a beam, you have broad on the bow, on either bow. And then aft of the beam, 45 degrees to the stern, you have broad on the quarter. So you have broad on the bow and then broad on the quarter. And then in between those, there's 3, well, it's a total of 4, but 3 more little things until you get to that 4th to divide up where something is. So you could say, you can say 1 point to port. So it's going to be not quite dead ahead, but slightly to port. Or you could say 2 points forward of the beam. So it's not for the port beam. So it's not right on the beam, a little bit forward of the beam, or 2 points past the beam. So you're just giving directions from those kind of those 4 points, either the bow, the stern, or either beam. Again, the point system doesn't work if nobody else knows it on board, right? So if you say, oh, you know, you're broad on the starboard quarter and no one knows where the starboard quarter is on board, then it's pointless to say that. Like, communication and situational awareness is key on board your vessel, no matter what size it is. So whatever system works for you and the people you're boating with, your family, your friends, whoever, use that system. This is just that fancy word. Okay, let's get into it. Enough rambling, Bree, right? I'm a rambler. Let's talk about compass error. So typically, most like, and so kind of for the rest of the evening, we're really going to be focusing on the magnetic compass and compass error in relationship to the magnetic compass, because you will be seeing a magnetic compass. You will most likely be seeing a magnetic compass on board. So there are 2 things that change that magnetic compass from pointing to magnetic, pointing to true north, versus what your compass is reading. So compass error is the difference between what your compass is reading and what true is. And there's 2 things that can change that. The first one is called variation, and that's going to be the Earth's magnetism. So where you are in location to the poles, in location to volcanoes, in location to all sorts of things, on the Earth's magnetism is going to change that compass. And then you have deviation. Now, deviation is going to change based on your boat's magnetism. So do you have a bunch of lead up forward, or something that's changing the magnetism on your boat? That's going to change how that compass is working. So, so those are our 2 things. Now we're going to dive into each one. We're going to start. Yes?
So is there a reason why we have to have 2? Can't we just go true? Why can't we just use true north? And ditch the magnets?
Because your compass on board is going to be reading magnetic.
Yeah, this is kind of a history question, I guess. Why? So on board you need the magnetic because that's how you can get direction, whereas you can't really get true north direction.
Yes. So we want to, we have those 3 types of compasses: your gyro, your satellite, and your magnetic. Magnetic is the only one that doesn't require that power source. So we always have that magnetic as like a backup or our primary steering tool. And there will be a difference between how that magnetic compass is reading versus what true is. And so we need to account for that difference.
Okay. So it's about power. It's about powering a compass.
Yes.
Okay.
Yes. So we always have a magnetic because that's, I would say, the most reliable. It's always gonna, it needs no power or source or anything like that.
Got it. Okay, thank you.
But there are things that affect it. So we need to take into account those things, meaning the Earth's magnetism and the boat's magnetism. So first, yes, Sam?
So true is pointing to the North Star. Is it based on celestial navigation?
True is our geographical true north, where all of those meridians meet.
I see. Okay.
Right at true. The magnetic North Pole is not going to be the same as the true North Pole.
Gotcha.
So our true is kind of this geographically true north. Okay.
Hey, Bree.
Okay, so
Bree, sorry, one more question. So on the electronic compass that is on most boats, so let's say it's a satellite compass, will that be always correct to magnetic north? Or
No.
true? Or
It,
true?
it is going to be most likely, it is going to be aligned with true north.
Okay.
And you would always want to check that, just like you would check a gyro. You want to be able to say, yes, I have a compass error of 0, or I have a compass error of 0.5 east. You know, it's very minimal when you're talking about a gyro or a satellite compass. With magnetic, our compass error could be, 20, 25 degrees or something. But no matter which compass you're looking at, you want to be able to calculate that error, so then you know.
Excellent. Thank you.
Okay. Okay, so for variation, this is the difference between the magnetic North Pole and the true North Pole. Those two things are not equal. So again, our geographic North Pole is where all our meridians meet at the top of the globe. But our magnetic North Pole is always moving around, and it's where the magnetism of the Earth is at our magnetic North Pole. That would be where that Polaris is pointing, the North Star. So let's go to the next page. Here is a map of our magnetic North Pole and how it has changed over the years. And as you can see, the last 50 years or so, it has just taken off, and it is moving a lot quicker than it used to. So our variation does move. I am not a, geologist, or I don't know why it's moving, but I know that it's moving, and I know that the really smart people can predict where it will be moving, or predict out a little bit at least. So we have this annual change in our variation that we are taking into account as well.
I'm a geologist, so I know something about this topic. The magnetic pole is a result of the spinning of the Earth's core, which is liquid metal primarily, very high in iron, and so it's spinning, and that creates the relative to the crust inside the Earth, and so that generates the magnetic north. But there are little eddy currents that occur, and hot spots where it deforms out of its spherical shape, and then that's what affects the net location of the magnetic north.
Yes, and that's where we get our difference in variation lines, which we will see. I'm going to bring it up on here. I'll go back to those slides, but this is our variation lines, how they change all over the globe. So it isn't quite, parallel and perfect and even and predictable. They are curvy lines that I don't know how to predict, but John knows more than I do on that. What was that? Okay, so let me go back to this one. Variation. The Earth has these magnetic fields. Oh, maybe John, you can check. Is this a true fact here? Over 9 million years, there's been 12 reversals of the Earth's polarity.
It is, yeah. That's how they correlate the various rock units, is by looking at as magma cools, then the iron-rich particles align to the magnetic field. So they know this very accurately over history.
Very cool.
Yeah.
So yes, the magnetic fields on the Earth's surface are always moving, but those magnetic meridians, so when we talk about our magnetic heading, we're talking about in relationship. So our 0 is our magnetic North Pole, where our true heading, our 0 is our geographic true north. So we have our magnetic north, our true north, and then we're also going to have our compass north. So we have those 3 things that we're going to
get one of those flying things in here.
So is the variation the same as declination, which is used on topographic maps? Essentially the difference between true north and magnetic north, and they call it the declination on terrestrial maps.
Okay, yes.
Yeah.
I didn't know that. Celestial, we have declination, and that's a totally different thing.
Hmm.
But yes, it's the difference, variation is the difference between our magnetic north and our true north.
Question, Captain.
Yes.
Sorry. So if there's so many irregularities in the gravitational field in the compass, depending on location, and you're depending on the compass to tell you where you're going and where you are, how can you tell where you are if that changes from location to location?
So our charts, wherever we are located on the chart, is going to tell us our variation. So all of these little different curves of the magnetic meridians moving around the Earth are on our charts. The actual variation curves are not on them. I've seen some piloting charts that have it, but they're not on it. They're on the compass rose, which I have another slide of where to find that variation.
Okay,
and
so
how it's calculated.
To find your location, you don't depend on the compass, but you depend on like the sextant and so on to get your location, and you find that on the map, and then from there you can.
So hopefully, generally speaking, you know what ocean you're in, and are you closer to San Diego or closer to LA, and you could use a variation for either those general areas. Yes, if you're crossing a large ocean and you don't have any sort of electronics or power on board, you can use the sextant and plot your position using no compass at all, and figure out your position there, and then go back to the chart to see what your variation is. So that's a possibility, but yeah. Okay. So variation, got this. Where is our variation found? So on our compass rose, so is this our compass rose on the training chart? Oh, it's not. So this compass rose, we have a variation of 4 degrees and 15 minutes west. So that is saying our magnetic north pole is west of true. So here's our true. Our magnetic north pole is west of true. So our variation gave us a degree to say which side is it on and what value is it. It's 4 degrees. And then because our magnetic fields are always changing, they're going to give us this annual increase or decrease. So in this compass rose right here, we have an annual decrease of 8 minutes. So that's 8 minutes of a degree. And for all of our purposes here, and for most of our purposes in general, our variation and deviation, we're going to round to the nearest degree. So that annual increase and decrease by a single digit minute is going to have very little change to our degree of variation. So most of the time, you can just use this variation 4 degrees west. So just variation is 4 degrees west. That's the information you're pulling from the chart. Now this one over here is from our Long Beach chart. They're the 18746 that we use. So we have right off the coast of Newport, we have a variation of 12 degrees east, and that was in 2017. We have an annual decrease of 5 degrees. So in the last 3 years, it would have decreased 15 degrees, and that is not going to change our whole degree that we are going to use. We are still going to use 12 degrees east. So with that 12 degrees east of variation, we're saying from us, where we are, where this compass rose is, which I'm telling you was off the coast of Newport, our magnetic North Pole is east of the true north. So that's what our variation is, because it's towards east.
So when plotting a course, would you just use the inside of the compass rose to know your magnetic heading?
So when we plot our course and our bearings, we always want to plot them as true on the chart.
Okay.
Now, I've heard of some boaters taking, or I guess I'm going to say, they're magnetic, but it gets trickier when you are trying to get a fix with 3 or 4 different bearings. You always want those in true. So I guess I'm just going to say, for this class, you always want to use that outer ring, that outer compass for true. So everything on the chart is true. Everything we put on the chart and everything we read and take off the chart is all in true. But that inner circle is pointing to the magnetic North Pole, which is not what our compass is pointing to. So our compass is pointing to, because we have our compass north, because we have, our magnetic differences of the boat. So first we took into account variation, which is the Earth's magnetism. And now, if I can do it, we're going to take into account deviation, which is our boat's magnetism. So what could cause our compass on our boat, instead of pointing to magnetic North Pole, why would it change one way or the other?
Metal on board or some magnet on board or something.
Metals, magnets,
Alternators.
alternators, engines,
Batteries, yeah.
batteries. If you have a pocket knife sitting on top of your compass, if you have a radar, what else do I have? Cell phones. All these different things have little magnetic poles, I guess, that can go one way or another. So your deviation can change. It can change significantly if you, load something completely different on board than you have had before. If you, change out an engine, or if you are completely full, it can change if you change your boat's layout significantly. But day to day, it's not going to change that much unless you have, a very strong magnet very close to your compass. Then it would change significantly. So you want to avoid that. But how do we read, or how do we know what our deviation is? We use a deviation table. So on the side here is our US Coast Guard's deviation standard format. You can print that online and create your own deviation table. The middle one, I think this one's from the book. It's an example of how someone did it. And then the one on the side, on the right side here, is my husband's ship. He works on a container ship for Matson. And they just, I want to say it's a new ship, but now it's over a year old, so it's not too new anymore, but it's a relatively new ship. And they swung the ship and created their deviation table. So your deviation table is relative for your heading. So we want to keep that in mind. Do I do this in the next slide? I think I do here. No, okay. So I'll keep looking at this. So wherever your boat is pointed, I think I have a little boat here. Wherever your boat is pointed, if you have something that's pulling your your compass away from north here, and as you change heading, it's going to have a different pole on your compass as your vessel changes heading. So your ship's head is always the I don't know, steady factor in these deviation tables. So your ship's heading will be standard, and then your deviation is what gets filled in. So how do you do this? It's called swinging the vessel. And how you would do it is you'd stay relatively, you could pay a company to do it, or you could stay in a relatively same area with little to no current, and then you change your heading and take bearings off of known objects, so off of pieces of land or day markers or buoys or lights. I like to say get 8 or 12 bearings, and then you can say, okay, from true north to here, I had a to 45. This true bearing I can get from the chart. I can get my variation from the chart, and then I can calculate what my deviation was. So if my heading is somewhere in between here, I can just use that, as my deviation. And that's how they create deviation tables. So for our class, we have a deviation table. This is going to be towards the end of your packet that you got in the mail or you picked up in class. I also posted it on the Google Classroom, but definitely print this out and have this handy because we are going to be using it on pretty much every assignment from here on out. We are going to be using this deviation table. So typically on larger vessels, they have the deviation table posted next to the helm, so you can see it as a helmsman. I would say I don't see that. That's very unlikely in the recreational world. I don't know. For you guys, anybody who's been on some recreational boats out there, have you ever seen a deviation table?
The deviation table is specific to the vessel that you're on.
The vessel, yes.
Okay.
I have
Okay,
not seen
so-
them on a boat.
Bree, my question, why wouldn't you just have the compass calibrated then? Why would you risk having a deviation? Why wouldn't you just box the compass and get it calibrated?
That was my question too.
Yeah, I guess that's a good question. And with the binnacle and our magnets, we can change our deviation to be as minimal as possible on very large commercial vessels.
It wouldn't work though, would it? Because if you change the compass, the change you make to the compass isn't constant because it depends on the heading, where a variation is constant. So it sounds like you could actually program a variation if you were going to boat in the same place all the time, but the deviation is different based on your heading.
Yes.
That's true for magnetic compasses only, though.
Yes.
It's
So
to do with parts of the boat. I mean, if there may be more deviation astern than ahead, right? I mean, so it matters which direction you're going. That affects
yes.
the deviation.
So deviation is all dependent on which direction your boat is facing and where that magnetic North Pole is, and what magnetic things are pulling on your boat. So you could try to get variation as low as possible, and typically it is very low. I would say if you have a variation of more than, a deviation of more than 10 degrees, you should get your compass overhauled by a professional. But it's not too hard to create a deviation table if you want to. Now, with US sailing or, with US sailing, when you have, I don't have one at home here, but I had one in the classrooms, the handheld magnetic compasses, they say those do not have any pull, no deviation, that handheld compass is pointing directly to magnetic North Pole. And there is no compass north. Now, if you're testing for a Coast Guard exam, that does not exist. You will always have something different. Your compass will always be different than magnetic north, which will always be different than true north. US boating or US sailing, which this is kind of like a prerequisite for that class, says if you have a handheld compass, it is pointing to directly to true north, that you don't have any deviation. So I might have just confused you there.
So the magnetic compass is actually calibrated for true north, but it has to be, it depends on latitude and longitude. It's not always the same though.
Magnetic,
Magnetic, yes.
not true.
But no, the compass that you have in hand, the handheld compass, that's magnetic, right?
Yes, that's a magnetic compass, and it's always pointing to that magnetic North Pole.
Oh, the magnetic North Pole. Okay.
So they're saying if you have like a magnetic necklace on or something, that it wouldn't change what your handheld compass is. For my theory is there's always going to be some sort of deviation, but that could be so minimal that it's just not taken into account, I guess.
So how often do you check deviation on your boat?
After a significant change. So after you brought it out of shipyard, if you changed an engine, if you know, took off the fly bridge and mounted some fishing things, or after a significant change on board.
Got it. Okay.
Okay. So deviation table, swinging a ship. Okay, now we're going to get into calculating that variation and deviation. So has anybody heard of, so this is our formula. We have true, apply your variation, east or west, and you will get magnetic. Then you apply your deviation, whether it be east or west, and you get compass. So we have our true bearing or heading. We apply our variation, then it's our magnetic heading. Then we apply our deviation, and then it's what our compass is reading. So with this equation, we have our variation and deviation will both have a sign or a value to it. It'll be east or west. If we are going from T to C, we're going to be adding west, subtracting east. So TVMDC, add W minus east or minus E. I know some of you have had my class. Does anybody know a poem of how to remember this formula? Anybody heard of? Okay, so.
I remember from the last class.
Okay, you remember the last class. Okay, I don't.
The only thing I remember, actually.
I won't go into the poems just yet. Okay, so another way of looking at this is if we have our compass and we are going to true. So we have what our compass is reading, but we want to know what it is true. We apply our deviation to get the magnetic, and then we apply our variation to get the true. So if we're going from C to T, we are adding east. And this is the same thing, just flipped in reverse. So just this order of things, whether it's TVMDC or CDMVT, these are our poems that we are memorizing, and everyone has learned this a different way, or brain works differently. So I'm just kind of covering all my bases here. Okay, so The one I like to teach for TVMDC is TV makes dumb children add west. So that's how you could remember the T, the V, the M, D, C. Just a little poem rhyme. The non-politically correct one, so saying it here, not politically correct, but it is the most common sailor one that I hear out there, is true virgins make dull company, add whiskey, subtract ethics. There are lots of creative other people out there that can come up with one that's not as politically incorrect, but that's the most common one people remember. So I'm gonna put it on here anyway. The most common one for going from C to T is our can dead men vote twice at elections. This is the one I learned at the very beginning of when I was studying this, so I always go back to this. You might hear me mumbling, can dead men vote twice at elections, because that's the way I remember it. Another one I heard was cow dairy milk is very tasty. If anyone, does anyone have any other poems that they've heard of out there? I love adding more to my little PowerPoint here. Well, if we have any creative people in the class that want to create a new one, that could be fun. Okay. So let's talk more about this. So now we have compass error. Now compass error, so we have variation and deviation, and then sometimes we'll just talk about compass error. And that's going to be a combination of variation and deviation for that specific scenario that we're talking about. So your compass error is always the difference between the true heading or bearing and the compass heading or bearing, whether that's a gyro compass, a magnetic compass, a satellite compass, whatever that compass is, the error to get it to true is going to be your compass error. Okay, and that compass error is going to have a value of east or west. It's going to say it's pointing to the east of true or west of true. So we always label deviation, variation, and compass error to the east or to the west. So now I have, these are kind of visualizing some things for us. So we have our true north, right? And that's our 0. Our heading in this case is 320. So from true north, we are 320 degrees clockwise. And that's where we get our heading. So that would be our true heading. Now, if I see what my variation is, my variation in this case, do I put my numbers? No. It's going to be west, right? Because here's my magnetic North Pole. And here it says my magnetic is pointing this. This is where my magnetic North Pole is. Is going to be, let's call that 11 degrees to the west. So if I was reading my magnetic North Pole, I would read here, what would I read here? 331? It's hard for me to read that. 331. So that west, going from true to magnetic, we would be adding west. So yeah, that would be 331. And then we have deviation, which is further. So our compass, so this inside ring is a visual of what our compass is reading. So our compass heading is, or our compass north is even further west of that magnetic North Pole, which means our magnetic or our compass heading gives us I don't know, 345, something like that. I can't really read it, 340. Where our true heading is 320. So there's a significant difference in what our compass is reading on board versus what our true heading is. So this is what we want to kind of visualize when we are doing this TVMDC thing. That we have true, magnetic, and compass. Those are three different things that we are measuring. And east or west is describing it. So here's an image with our variation and our deviation going east. So our heading is still the same. And then we have our magnetic heading is to the east. So you can see it would be less than that. And then our deviation is even further east. So it's less than that one. So here's my 0, and I'm going all the way around. Here's my 0 going all the way around, etc. Here's one where we have variation one way and deviation the other way. So they're counteracting. So I'm going to go back to this one real quick. Our CE is our compass error. So our compass error is our combination of variation and deviation when they're the same. So then when we look at when they're different, our compass error is much smaller than, say, our variation or our deviation. It's the combination of the two. It's the difference between what your compass is reading and what true is. So here we have our variation. So our magnetic North Pole is to the west of our true North Pole, where our compass is east of our magnetic North Pole. So it's not east of true, it's just east of the magnetic North Pole. That's what you're measuring your deviation from the magnetic North Pole to the compass. That's your deviation. Okay, now we're going to practice. How are we doing? Doing okay? Okay. Great. Good enthusiasm.
So are there actual equations then? I mean, I'm used to the way you had where you wrote it out before with where they were listed from, true, variation, magnetic, deviation, etc. Is there just an equation that summarizes this for the two or three options?
Yes. So we're going to do that right now.
Okay.
So in our practice, we have a true course of 045, and then we read on our compass rose on whatever chart we are using that the variation is 10 east. What should my compass course be? So we are going from true to compass. So from T to C. So here's my little formula. So I'm starting at T and I have 045. I have variation, which was given to me. And then I'm going to apply that variation. So it's east. So according to my rule, if I'm going from T to C, I'm going to add west, subtract east. I'm going to subtract this 10. And I get, oh, I skipped a little here. I get 035. Then using that magnetic heading, I go to the deviation table. So that deviation handout that I gave you, you're going to go into the magnetic heading of 035. So we go to where 035 would be in between these. And again, it's that range. And we get 3 degrees east. So that's going to be our deviation used at this heading. Then I go to my compass, or I apply that 3 degrees east. And again, it's subtracted because it's east, and going from T to C, we're subtracting east. And we get a compass heading of 032 per standard compass. Now, T to C, that confuses a lot of people. PSC, I've heard it, people say it means different things. I learned it as it means using the standard compass on board, meaning the compass that is in line with your center line, that's on the center line. You could have a compass at your steering station, which might be closer to starboard, or you might be taking this bearing or something off a bridge wing on the port side or on the stern, or you might have different compasses around. So your standard compass is the one on the center line. I've heard also people just call it per ship's compass. Doesn't really much matter in this class. It is, so PSC is what we term for what our compass is reading. Degrees true or degrees T is what we use for true. For those fun facts out there, PGC is going to be per gyro compass, and that's if you have a gyro on board, which you will see in your higher Coast Guard exams. You won't see it on the 100-ton exam, I don't think. Okay, let's do another one. This time, we're starting with our compass course. So on board, I am steering 180. So I'm steering due south according to the compass on my boat. What is my true course? What am I doing true? So I can plot that on the chart. So I have my my formula. I did TVMDC, but then I'm going to start at the C down below. So going this way from CDMVT, I'm going to add east. So I've put in my information. I have my compass is 180. My variation is 12 east. I got that from the compass rose. So my first step from my C to go all the way to T is to find what my deviation is. So I go to the deviation table, and on compass heading for 180, I get a deviation of 1 degree west. So from C to M, I'd be adding east. That means I'd be subtracting west. So I'd get a magnetic of 179. Then I'm going to apply my variation. Yes, variation. And it's 12 east. I'm going to be adding that east to get 191 degrees true. So that is what my true compass is, or my true course is, versus what my boat's course is doing.
Why did you subtract 1 degree west? Why was it subtracting?
Going from C to T, I am adding east, subtracting west. So I had 1 degree west, so I'm going to be subtracting it. I usually like to write both them. I don't know why I don't have it on the PowerPoint like that. When we're going to do some together, and I'll show you how I write it out when we do it on the chart. That will hopefully make a little more sense to you.
So see, you're adding west, subtracting east.
Yes. Some people like to say going down, you're adding west. Going up, you're adding east. If you're going from T to C, that's down. Or if you're going up. But it all depends on how you write it, I guess.
So what this would look like on our compass would be the lubber line pointing straight down, right?
So the lubber line is always going to be on that C.
Oh,
your lubber line
sorry, yeah.
on your compass is going to be the value of C.
Okay.
Okay.
So if you don't know your deviation on your boat, would you always add deviation even though, I mean, like make a guess? Like you got to put something in there, right?
If you have no clue what your deviation is, then I would just go for magnetic and apply your variation, and just be cautious of, you might have some sort of difference. So you want to be checking your position, checking your heading more often, and not just like put it in autopilot and then like go down and take a nap or something. You don't want to do that in general.
That is never going to happen on my boat. I'm telling you.
Okay, so you just want to be checking more often that you're where you want to be.
But you said 3 degrees is your,
My
don't ever
window.
be more than 3 degrees off. But some
Yes.
of these deviations are bigger than 3.
Yes. And this is a made up fictional, I didn't make it up. I don't know who did.
But it is possible that your deviation is 9.
Yeah, that's the highest value on here. It is possible. I would say you want to adjust your compass if you have that high of a deviation. Does anybody know of a local company around here that will give you a deviation table? I know of big boat ones, but not recreational boat people. I'll look into that.
Well, you can always find that yourself using the
Yes.
reference on the chart. Okay.
Yes, you could find it yourself. Okay, so to finish up our PowerPoint, and then we're going to dive into practice. We're going to talk about a little bit about bearings and LOPs. We're going to dive real deep into this next week, but this is just a little overview to help us with our chart plotting today. So there are, I actually want to show, before I get into this. Oops. Okay, can you guys see my whiteboard? My little boat?
Yes, we can see it.
Okay, so here's your land. Maybe here's a lighthouse. Here's a buoy. Just drawing some stuff. Okay, so here's my boat. This is going to be my heading. Wherever my boat is pointed, that is my heading. And then I can get bearings. A bearing is saying, oh, this lighthouse is right off of my beam. And we'll make this one not off the beam. This buoy is broad to port. So this is a bearing. So my heading and my bearings are different. If I had a lighthouse right here, say this is what I'm steering towards, maybe it's a safe watermark, right? We like to steer towards safe watermarks. If I'm steering towards a safe watermark, my heading and my bearing would be the same. If I'm taking a bearing not from my directly ahead of me, then my bearing and my headings will be different. So our big thing here is heading versus bearing. So those are two different things, but remember on our deviation table, we could highlight it as a group here, circle it, do whatever you want. This is always by your heading. Always, always on your heading for the deviation table. Your heading and your bearings might not be the same. They could be the same if you are headed towards what you're taking a bearing from. But if you take multiple bearings at the same time, your heading isn't changing that quickly. So your bearings are going to be different than your heading. Okay. So this is a typical way of getting a simple line of position is from being on board and saying that light is bearing, here's due north, it's bearing 045 degrees true. So from that light on the chart, here's that light, I can plot a line of 045 on the chart, and by getting that little piece of information, let's say at 7:45, so that's 1945, or you're going to be using military time, I am somewhere along this line. I'm in infinite possibilities along this line. I could be here, I could be here, I could be here. All I know is that from wherever I am, that light was bearing 045 at 1945. So that is a basic line of position that we're going to be using. Let me go back to the PowerPoint. I probably have some better drawings of it than my little drawing. Okay, so a couple types of LOPs here. We have a bearing from a buoy. That's your typical one that we're going to use here. So from that buoy, we know our bearing is 320, and then this one is our time. Another one we have is a distance. So I can say, if I had a radar on board and I figured out that I was 4 nautical miles away from this island or this whatever, I can draw an arc that says I am 4 miles away from that land, and that would say I'm somewhere along this line. I don't know where I am, but if I'm at 4 nautical miles away, I'm somewhere along that line. We have a tangent bearing, meaning we have a bearing that only touches a piece of land once. That's typically taken on a radar. Again, most of us aren't going to use radars. And then we have a range, and I will go back and back and back and back. I love ranges. Ranges are great for recreational boaters because with a range, you don't need any sort of instrument. You don't need a compass. You don't need any sort of instrument to measure it. You just need 2 objects out in the distance, whether it be a piece of land and a buoy, whether it be the end of a pier and end of the jetty, or 2 pieces of land or 2 buoys or whatever it is. You just need 2 objects in the distance that are in line, and then you could say if those are in line visually, then if I connect them on the chart, I am somewhere along that line. So that is called a visual range. Those are also really great to swing your vessel and get your deviation table using visual ranges, just because they're quick and easy. Okay. Now I go into examples, I guess. This is a visual range. So this is saying these 2 things are in line with one another, then I must be somewhere along this line. To get a fix, and again, we're going to go into this much deeper next week, we need 2 lines of position. So we would need a bearing and another bearing, or a bearing and a distance to get an actual position. This is illustrating the differences between our bearing and our heading. So our heading is going to the east, and then we have a bearing from the lighthouse and a bearing from the buoy. So without changing headings, we can take bearings from different things.
You get your bearing from 2 fixed positions, but not your distance, right?
Correct. Your distance, it is very hard to get distance without a radar on board.
Okay.
So typically for the recreational boater, you're not going to be getting a distance measurement. Does anybody have a tool on board, a rangefinder or something that has been a reliable tool to measure distance in the recreational world? Okay, I don't know of one besides radar.
Aren't the bearings that are normally taken magnetic bearings that are taken with like a handheld device, you know, not true bearings, but magnetic?
Yes. So then we need to convert them to true using our TVMDC so we can plot them on the chart. Okay.
Excuse me, Captain. Can't you get your range from 3 fixed objects? And then you see where you are on the map from 3 fixed objects?
That would give you a position.
Position, and from the position on the map, you can tell the range, right?
Yes, yes.
Okay.
Okay, so your deviation table, again, is based on heading, not bearing. So it's always based on heading. Okay, now let's quickly talk about relative bearing, and then we're going to take a little breather. Okay, so everything that we've been talking about before this has had true north as our 0 mark, right? Everything has been measured clockwise from north, whether it be magnetic north, true north, compass north, it's all measured clockwise from that north as 0. Now, with our relative bearings, we're going to switch that and say our 0 is where our boat is pointed. So where our heading is our 0. And our relative bearing going clockwise from the bow is going to be from our 0 point. So this is kind of like that. Are we at 3 o'clock, at 6 o'clock, at 10 o'clock, whatever it is. But in order to convert that bearing that we get relative to put it on the chart, we need to convert it to true. Because everything on the chart is true. I'll say that again and again. So this is an illustration. So north is pointing up, which we always have north pointing up, and our heading is going to be clockwise from there. So this is our heading. Our relative bearing is going to be relative from our bow. So if we add our boat's heading and our relative heading, we would get the true bearing. Excuse me, the boat's heading and then the relative bearing, we would get the true bearing. So this is another visual of it. We have our ship's heading, we have our relative bearing, and then we'd add those up to get our true bearing. So I like to, here it is, put it in a formula. R plus S equals T. So relative bearing plus your ship's heading equals your true bearing. Now, okay, I'm going to go back to this. So here's an example of it. I have a relative bearing of 135 for this object A. So from my ship's heading, clockwise, I have 135 degrees. From true north to my ship's heading, that's my ship's heading, and that's 45 degrees. If I add those up, I get what my true bearing would be. Now, to get relative bearing, to measure that, to measure that on board, is, it's hard. I would say we will typically use it in a kind of a shortcut or quick and easy kind of way. If we see something on the beam, if we see something on the bow, if we see something on the stern, like something maybe we could line up the structure of our you know, the cabin or two bits in line or something that we could use on the boat to help us get a relative bearing. But most likely we're going to be using handheld compasses to get our bearings. But this is just a way of describing what a relative bearing is. Okay, so we just did that one. We had 45 plus 135 gave us 180. Now, if we are going the other way, say we are going to this object D, we have our ship's heading of 45 is the same, but our relative bearing is always, our standard relative bearing is always going to be clockwise. So it goes from our heading all the way around. So in this case, it was 340 degrees. Now, typically, if you're out there, you're going to say, oh, it's 20 degrees to port, instead of saying it's 340 degrees relative. Like, that's a large number to visualize out there, where 20 degrees to port versus 20 degrees to starboard or something is a little bit easier. But again, with the way that the book likes to talk about this, our relative bearing is always clockwise from our ship's heading. So if we go back to our formula, R plus S equals T, we get a large number that is over 360 degrees. So it is going from true north all the way around and a little bit more. So in order to convert that into something that we can use, we subtract 360 degrees. And then we get 0.25. Does that make sense? Any questions with how I did that? Okay. Okay. Now we're going to get into our plotting assignment. So let's take a 10-minute break here. Let's come back at 8:05. And with the Long Beach San Pedro Channel chart. So that 18746 chart is the one we're going to use for assignment number 5. All right, I'll see you in 10 minutes. All right, everyone get their San Pedro channel charts out. Getting there, cool, cool,
Yes.
cool. So we are going to work on, let me share the screen here. Ah. Okay, so we are going to work on assignment number 5. So this is our chart correction exercise using the chart. The other 2 homework assignments, number 6 and number 7, do not use a chart. They're just exercising compass error, variation and deviation, and relative bearings as well. So you don't need a chart for those, but for this assignment 5, we're going to do the chart. And for those of you who took my weekend workshop series this summer, this is the same assignment that we did during the summer. So this will be the only same assignment that you have. So they'll be different from here on out. If it looks familiar to you, yes, it is the same, to answer your question. Okay. Any questions before we start? Everyone have the assignment? Let's see. I'm going to be using all of the chart tools. And I also apologize. I get a new chart each year. So this being my last class of 2020, I've done this same worksheet on this chart a lot. So I think this is the 5th time. So it's kind of already etched in the chart, but I'm still going to do it. Okay. Anyways, this will be, let me bring it closer to make sure you guys hear me. Okay. So we're starting on assignment number 5. Not closer to me. So they are telling us on number 1 that we are sailing on a course of 298 per standard compass. So per ship's compass, or per my boat's compass, I'm steering 298. At 8:30, okay, so I have a time. At 8:30, I take 2 bearings using my ship's compass. And I find that the Hogue Hospital is going to be bearing 061 degrees PSC. And then I also find that the southeast stack of the Huntington Beach Power Plant, so I'll call it HB Power Plant, is going to be bearing 007 degrees PSC. So, and then it asks me what is my position and what is my true course. So now I want to plot the information that they've given me, or that I've gotten from my boat, onto the chart. And everything on the chart is true.
So what does PSC stand for again?
Either per ship's compass or per standard compass. Where did my markers go? Okay, I guess I'm using this one. Okay. So
How did you get your 2 bearings?
Using my ship's or my boat's compass. So my compass was on board and it was pointing. Where's my little boat? There's my compass on board, and using that compass, I aligned something to say, okay, that's 061, and that over there is 007.
Got it. Okay, thank you.
see if I can go back. I'm gonna share this screen real quick. Okay, you guys see the PowerPoint? So see how on this lower compass, so this is how you would do it on a larger vessel. You line up two things in line to something on the horizon. In this case, they're measuring what the sun is bearing. So it's kind of that same concept with land features as well. But on a little boat, it would be a lot harder to do that. So you typically use the handheld compass that has the two little marks. If anyone has a handheld compass at home, you could show it to us. We have them in the classroom, but I do not have one at home. I'm sorry, I can't show it to you.
I have one.
Okay, so it has two little pegs, right? Or you have one on your phone. People use that one too, yeah.
But
so
I know we're not supposed to do that.
No, you can do whatever you want to do.
Yeah, the phone is a gyro compass, by the way.
Oh, really?
Can you toggle it back and forth, or? Oh, Tim is showing us a handheld compass. It has two little things that you are aligning with something in the distance, right? Yeah. So that's how you're taking these bearings. So you're not. So also, if you don't have that handheld compass or your phone or whatever it is, you can. A quick, easy way, maybe not quick and easy if you're on a sailboat, but you can turn your vessel to line up with that lighthouse or that object to make your heading equal your bearing. And if it's dead ahead of you, your heading would equal your bearing, and you could get an LOP that way.
And this one, is this true? No.
I don't know what it is on your phone.
Technically, it is true, but it depends upon what type of phone you have. They are a gyro-based compass. It's based off of an IMU sensor, and the error rate is less than 0.001%. So it's actually pretty good these days.
True.
Depends on your who's your supplier of your phone. The worst supplier of the phone is the Apple phone, the iPhone.
Interesting. Fun fact. Okay. All right. Let's dive into it again, just using the bearings that they gave us. So we have it per compass. These are in C. We need to convert it to true to put it on the chart. So I'm going to do TVMDC. That's the most commonly used one, so I'm just going to use that one first. So if I'm going from T to C, I'm going to be adding west, subtracting east. I'm going this way. If I'm going this way, it's going to be opposite. So I would be adding east, subtracting west. So I'm going to make kind of a little table here. So my first column is going to be my heading. My second column is going to be Hoag Hospital. My third column is going to be the Huntington Beach power plant. What I'm looking for is a true value, so I can plug these, so I can plot these on the chart. So compass-wise, my course heading was 298. My Hoag compass bearing was 061. And my HB power plant was 007. So now I'm going to work my way up. So I am using these rules of thumb and not these, not those ones. So I'm going to go to my deviation table. So grab your deviation table. And I have a compass heading of 298. So I'm going to find a compass heading of 298. If someone said it, what was it?
6 west.
6 west, yes. 6 west. So our heading did not change. So our deviation is going to be the same all the way across because our heading did not change. And our deviation table is based on our heading. Okay, so if we are following our rule, going from C to T, we are going to be subtracting west. So we are going to be subtracting this. And we get 292. We get 056. No, 055. And 001. Then we apply our variation. Where do we get our variation?
Chart.
On the chart. Let's see if we can rotate this down. Okay, so our variation tells us it's 12 east with an annual decrease of 5 minutes. So over the last 3 years, the annual decrease is nothing, rounded up. So we're going to use 12 east. Bring that back to north. Okay. So 12 east, 12 east, 12 east. So now we're going to apply this number. We have 292. Our east, we are adding. So we're going to add 292. We get 304. Yep. So now we have our true values that we can plot on the chart. So did everyone get how I came up with those? Cool. Okay.
Captain, one question
Yes.
on the variation, since it said 2017, if this was kind of a live fire exercise, would we then just multiply that by 3, given that it's 2020?
Yes. So that would be a decrease of 15 minutes. And we go to the whole degree. So 15 minutes, that would actually turn out to be our 11 degrees, 45 minutes east, which rounded to the nearest degree is still 12 east. So once you get to a point where your annual increase or decrease number is large enough and it was taken longer ago that it would change by over 30 minutes, that's when you would change your variation.
Great, thank you.
Cool. Okay. So now we're going to plot. Make sure I have this. So first we want to correctly identify the objects that we are taking bearings off of. That is always our rule number 1. That things that we take bearings off of must be plotted on the chart. And then when we draw our LOP from them, it must be the correctly identified buoy or object that we are looking at. So we use our roll plotter here. So we have here is our Hoag Hospital building. Here's Newport Boulevard, right? Here's our Hoag Hospital building. And then here are our Huntington Beach PowerPoint stacks. And we were talking about the southeast one. So that's going to be the closer one to the south. And in most of these questions, if you can't find it, they do give you the Latin long, so you can try to correctly identify it that way as well. Okay, so I'm going to the hospital building. So I'm going to line up on my roll plotter. Can we see it yet? There we go. A true Hoag Hospital was 067. So I'm going to line up 067. And then I'm going to roll it on up to my hospital and draw a line. So I am somewhere along this line. Don't know where yet, just somewhere along that line. Then I want to get the bearing to my Huntington Beach stack, which was 013. So I'm going to find 013. Okay, so I have 013 lined up on my roll plotter, and then I'm going to roll it back here till I get to my Huntington Beach stack, and then I'm going to draw in my LOP line. So where those two meet, which is going to be right here, where those two meet, that is my position. At what time was it? It was 0830, right? 0830. Now I'm going to plot in my course. So my true course was 340. Excuse me, 304. I can't talk today. 304. Line up a little bit further. Okay, so from my position, I'm headed up north towards Long Beach at 304. And now it asks us, what is our position? So we are now experts at finding our position, right? I'm going to line this up on the longitude. Draw in my longitude line. Draw in my latitude line. And I'm going to find my dividers. Where are my dividers? So for my latitude, from my position to that latitude line, I go over to the edge and I get 33 degrees, about 36.2. And then for my longitude, can you guys see the tab? No, you can't see the tab. Dang. Okay. 117.59.3. 117.59. Yes, that's 3 minutes west. All right, so we're pretty close to the answer I have on the book. This one was 3, but 0.2 is fine. And that's how we do number 1. You guys have any questions with that one?
With a triangle, would it be kind of like doing how we were doing the last homework assignment, but backwards?
I'll do it with the triangle. So I like doing bearings with a triangle. You put your pencil on the object, and then you put pressure on that pencil, and then we're lining up the focal point, and then 0, 6, 7 on the vertical line. So we kind of move this until we find the focal point in 0, 6, 7. Right about there. And then we can draw our line.
What are you using the focal point?
Am I using the focal point?
Yeah, I don't understand what you're using as the focal point.
So
The
where
whole
all of
thing.
the lines on the triangle come together,
No,
and
I
on this
understand
triangle,
that.
there's
So,
a dot.
so let me back you up a step. So when you were plotting, let's say from the hospital at 067 using the triangle, you would put the focal point on the hospital, correct?
On a vertical line. We put that focal point on a vertical meridian.
Okay.
And then the lower side of the triangle on the number that we're trying to find.
I
So
see.
0, 6, 7. So we have that focal point, that center on the triangle, and then 0, 6, 7. And then, so anywhere along this side is 0, 6, 7. So instead of having to move it one way or another to get to the object in question, that's why I like just putting my pencil down and keeping a little bit of pressure against my pencil so it's already lined up. I don't have to do any moving. And all I'm doing is finding these two things in line.
I guess the question is that you're drawing a line on the top edge of the triangle, but the focal point is lower than the top edge by a little bit. Does that create any error?
No, it does not. So let me line it up here. 0, 6, 7. So anywhere along this line is 0, 6, 7 degrees. If I move the triangle this way, it's paralleling at 0, 6, 7. So all of these lines are the same degree. So even if my focal point is on one line, it's still 0, 6, 7 on the other line. These are parallel lines to one another. Yeah, so this little black line, part of your focal point, and the outside of your triangle are parallel to one another. So it doesn't matter. Okay.
And can I ask one more question on that?
Yeah.
So if I'm looking then at the meridian line through the triangle, should it be lined up to 67 at that
Correct.
point? Right?
Yes.
Yep, I got it. Okay, thank you.
Yep.
Slow learner here. I got it.
That's all right.
Thank you.
Okay.
Captain?
Now we're going to do number
Captain?
2. Oh, yes.
Can you do one more time how you got the course of the boat, the 304, ideally with the triangle?
Oh, yes. So for the course of the boat with the triangle, here's my pencil. My point that I put my pencil on to pivot is my starting point. So in this case, it would be my position. So then I'm lining up that little focal point and 304 on my triangle.
Bree, hang on, I'm gonna back up one step.
Yep.
How did you do your position again, please?
So I plotted my bearing from the hospital and my bearing from the stack.
Okay, where they cross.
Where they cross, I put my pencil.
Okay, got it.
So I'm holding my pencil there. And then I put my focal point on the vertical line. And I kind of rotate this triangle around until I see it crossing between, 300 and 310, because we're trying to go for 304. So, and then I kind of line up my focal point and then try to dial in 304 and my focal point. So you see I have 304 hitting the meridian and my focal point hitting the meridian. And my pencil is already lined up on my position. So now all I have to do is draw my line. How you guys doing? Does that make any sense?
Yeah, and the line, we don't know where we're going with this, right? So the line's indeterminate,
Correct.
like how long it is?
Yes, correct. So we can plot it further out, and whenever we draw a line, as we know in our last homework assignment, we always look for hazards. So if I maintain this heading, am I going to hit anything along the way? Do I need to change course 5 miles down the road, 10 miles down the road, whatever it is? So just plotting that line helps us predict that.
Captain, sorry to ask, but could you just do the the 13-degree calculation with the triangle just one more time?
I'm wondering who is going to ask that one. So the 13-degree on the triangle is a little bit trickier. Oh no, I guess we will reach.
Triangle wasn't big enough.
Yeah, sometimes your triangle is not big enough, right?
Yeah.
That's the problem we're running into.
A little bit of guessing.
Yes. So I'm gonna go this way so you can see my triangle here. So anywhere along this line, I'm gonna line up the focal point and 1 and 1 3 0 1 3. So anywhere along this line, doesn't matter. I have 0 1 3 and the focal point on the meridian. Then I'm going to use a straight edge. So I have my triangle lined up. So I put pressure on my straight edge without jiggling it like I just did. Then I bump up a straight edge against it, put pressure on that straight edge, and now I can move this triangle anywhere along that long side of the triangle is 0 1 3.
Nice.
See how that paralleling this line.
Yeah.
So I'll line it up to that stack and then draw in that bearing line, that LOP.
That's good.
Thank you.
All right, let's do number 4. Hold on a minute here. I'm going to have to rearrange my camera. I'm going to put this.
Bree, while you're doing that, just a quick piece coming back. If you were using the parallel rules, then you would start at the compass rose and pick up your heading, and then you would walk it back to the points of interest, correct?
Yes, just like I did with that
The
roll
bearings.
plotter.
Okay, thank
When
you.
I started with roll plotter,
Yeah,
yep.
thanks very much.
Can I line this up? Okay, that's kind of it. There we go. Okay, let's try to get this out of the way. Oops. Oops. Uh-oh. Ah! Okay, might have to deal with the cord a little bit. Okay. Someday
Hey,
this will be
Captain?
nice and nipple savvy, but this works for now.
Sorry, Captain.
Yes.
I'm sorry, but I have to leave early. Is that okay?
That's okay. And remember, these are recorded and posted for the Zoom videos, so you can
Okay.
catch up what you missed.
Okay, thank you very much.
No problem. Okay. So, number 2. Number 2 tells us we are steering a course of 107 PSC, and then we take a bearings from 2 lights, Point Vicente and Point Furman, and that is at noon. So at 12 o'clock, Point Vicente is bearing 314 degrees PSC, and Point Furman is bearing 044 degrees PSC. So now we need to convert all of these back to true so we could put them on the chart. So in this case, we can do it the same way that we did last time. I'm just going to show you a different format. Maybe it's easier for some people or not. So again, it's the same basic thing, just plotted out a little bit differently on my whiteboard. Okay, so I do the same 3 columns. I do my heading, Point Vicente, and Point Furman. So same thing there. So in this one, instead of starting with T, I'm going to start with C. So I'm going to do can, dead, min, vote twice at elections. That's minus west. So I have my adding and subtract formula there. There we go. So now I'm starting with C, working my way to T. So it's a little more linear this way. So I'm starting with my heading of 107. I'm starting with Point Vicente at 314 and Point Furman at 044. So I go to my deviation for my heading of 107. So my compass heading was 107. So that will make my deviation 107. Is that my heading? Okay. 5 degrees east. 5 degrees east. My heading didn't change, so my deviation is the same all the way across. So looking at my rules, I'm going to be adding east. I'm going to add that 5. So that gives me 112. That gives me 319. And this gives me 049. Then I look for my variation. It's here on the chart at 12 east. I follow my sign. So I'm going to be adding. And I get 124 degrees true. .331 degrees true for Point Vicente. And 061 for Point Furman. So now I have my true, and now I can plot. Any questions on how we got this? So it was the same thing, last time I did TVMDC. So I started at the bottom and worked my way up. This time I wrote it backwards, started at C and worked my way down. Either way works. Okay, so now I'm going to plot these. I'll do parallel and then I'll do the triangle. Okay, so here is my compass rose, and I have another compass rose right here, but that's where my camera stand is. So I'm gonna try to use this one. Okay, so my first one, oh, another thing. Both of these objects that we are looking at are lights. So we're looking for the solid dot with the teardrop. So that is the light, and from that solid dot is where we're drawing a line. So Point Vicente light is right here. Point Furman light is right here. So we're going with Point Vicente, and it is bearing 331. So we're going to find 331. So I have that lined up. See, I think I'm going to do it a little bit this way. 331. We'll see if it works. I'm going to put pressure on this one. Move this guy. I think I'm going to miss it. Okay, we're going to try to save it here. I'm going to parallel it up and then try it again. So I'm putting pressure on this one. I have that silly little globe there, so I'm putting a lot of obstacles in my way. There we go, now we got it. Okay, so here's our Point Vicente. We'll line it up and draw our line. So I am somewhere along that line. Point Furman, gonna go this way. So we have 061. So let's find 061. Here's 061. And we're looking for Point Furman. We're going to find it that way. So here's Point Furman. Bump up against it there. And now draw in my line. So I have this one meeting with this one. So where those two cross is going to be my 12 o'clock position. We're going to get the latitude and longitude. Well, first I'm going to do the compass or the heading. My heading was 124. So let me plot that one real quick. 124. 125, 124, 124. Uh-oh. I would be able to reach that, but my camera, let's see. There we go, 124, okay. Get this one back. Okay. So then I also want to get the latitude and longitude. So I'm going to make a line to here and a line to there. So I have a parallel latitude line. Oops. Here's I almost could do this directly over. That might be easier because we're in the corner here. So right where this hits, I can draw a line over or draw a line to there. Same with the longitude. Line up my longitude. Put pressure on it. Oops. Bring it up to see what my longitude is. So I'll read this out. We have 33 degrees, 40.4 minutes north. And then we have 118 degrees, 24.6 minutes west as our position. Okay. So let me do that again with triangles. So for your triangle, Point Furman, put your pencil on Point Furman. We are looking for, there we go, for 061. So we put our pencil on Point Furman, our focal point on the vertical line, and then we're going to move this until that bottom of the triangle reads 061. There's 061 and my focal point, and then I could draw the line. Now with Point Vicente, it's right in the middle and it's closer to a vertical line. So we're going to have to move the triangle on this one. So let me show you how to do that one. Did everyone get how I did Point Furman? Okay. Point Vicente, my triangle is not going to reach. So I can go to this line or this line. Doesn't matter. Point Vicente is 331. So I'm going to put the focal point on the vertical line and then get 331 on the vertical line. So here's 331, get that vertical line. Okay, so here's 331, right? Crossing that vertical line. And then I have my focal point on the vertical line. And then I use that straight edge to move my triangle. And we always move our triangle using the short sides of it. So we could use this one or we could use this one. So I'm going to put pressure on the triangle, bump up my ruler against it, and then I could slide this anywhere. And this side of the triangle, this long side of the triangle is 331, no matter where I put it. So I'm going to line it up with Point Vicente and then draw my LOP line. I got that one. With my course, I'm going to put my pencil on my position, my fix. And then I'm going to put that vertical, the focal point on the vertical, and find my course line, which was 124. So I have kind of shifting it around here. Here's 125, 124. There we go. Oops. 124, bump it up against. And now you can draw your line. How do we do with that? All right. Now we're going to do number. Any questions with this one, or can we move to number 3?
You know, why don't you just give me the answer to number 2 and then you can just go on.
So this was our position.
The second part, just the position, please.
Oh, for some reason I have my longitude off on my. Oh, I read it wrong. That is not my longitude. This is my position. Yeah, 21.8 would be better. So we have 330 degrees 40.4 north and 118 degrees 21.8 west. Okay. So when we move to number 3 is going to be one of those handheld problems where we are using a handheld compass, meaning we won't have deviation. Again, this is for U.S. sailing questions. You won't see a question like this on the U.S. Coast Guard exam. Okay, so number 3, we are using a hand compass. We have at 1800, we have a heading of 100 PSC. We have a bearing of Ship's Rock. At 234 degrees magnetic. So that's not PSC. Oops. That's not PSC, that's magnetic. And then we have a long point bearing 157 degrees magnetic. So again, these are magnetic, not PSC. South here. Okay. Get that compass rose in there. Okay. Let's see. Am I going to do it another way? I'm going to go back to TVMBC. I think that's most commonly used. Going down, you are adding west, subtracting east. Going up, you are adding east, subtracting west. So we have our heading, Ship Rock, and long point. Okay. Okay, so our heading was 100 PSC. Ship Rock was 234 magnetic. So we go in at 234 degrees magnetic. We don't have any deviation.
Captain, sorry, at least in my handout, it looks like it says 160 PSC for heading. I just was wondering where you got 100.
Okay. I don't know which one's older or not. Oh, 160. Okay. It's just an updated version. Okay, because if you actually look at the deviation table for 160, your deviation is 0. So I thought it was a bad problem keeping it at 160 because it's kind of confusing that way. Like the point of this problem is that we're not using deviation. So I apologize for that. I'm pretty sure the most recent one is on Google Classroom. But I will double check that tonight. So that was number 3, heading 160 versus 100. So I'd like it to be 100. Okay. So long point, I have 157 degrees magnetic. Again, no deviation, no compass. So we're starting in on that M for those two. For variation, or I guess we'll do deviation, for 100 is going to be our 100 is going to be 5 east.
Wasn't there no deviation on a handheld compass?
Yes, but there is deviation on your heading.
Oh, okay, gotcha.
This is wrong on my answer sheet too. Okay, I apologize for the mistakes on this question. Okay. So let's focus on finding the position. That's the main point of this problem. So our variation, we look on the chart and we find that it's 12 east, 12 degrees east, 12 degrees east. We are going from C to T, so we are going to be adding east. We're going to be adding that. So 2, 3, 4 plus 12 gives me a true of 246. 157 plus 12 gives me 169 degrees true. And now I can plot these. I'm not even do the heading on this one because it's messed up on all the worksheets. I will fix it though. Okay. So let's plot the true. So I'm going to circle our true and we'll get our position. Okay, so Ship's Rock and Long Point are both on Catalina. So we have Ship Rock over here by the isthmus, 2 harbors. And then we have Long Point right here. It's kind of the area where Catalina sticks out. So for Ship's Rock, let's see. I'm going to do my triangle. Ship's Rock, I'm going to put my pencil on the rock, and then I'm going to use this side because it has white to find 246. So here's 250, here's 240, 246. Right there. So focal point and 246. And now I can draw my line. Right there. If you want to extend it further, you can put a straight edge on it, scoot it over, and extend it. Long point for the triangle is very close to vertical, so we need to do the moving of it. Our long point was 169. So we're going to find focal point on the meridian and 169. All right. Then I'm going to move my triangle. I'm going to put it on this one right here. Move my triangle to long point. So I get my 169, and where those two cross, it's my 1800 position. Then I want to find my position. I can use my triangle. We are very close to that latitude, maybe just 1/10 off, I would say. Yeah. So our position would be 33 degrees, 30.1 minutes north. And 23.3, that's 118, 2 minutes west. All right. Yes.
I'm like 0 for 9 on figuring out the triangle thing.
Oh no.
Putting the point, I lose. You tell me to put the pencil on the point, and then take the focal point to some vertical line and get to a course, and I can't make that happen. So if you could just pick one and try that again, I will try to keep up this time.
Yep. Okay. So let's try Ship's Rock. Okay. So pencil on Ship's Rock.
Pencil on Ship Rock.
Get this out of the way here. So then we're gonna. Oh, let's do it like this so we have less distraction. So
How do I know which is the best way to do it?
It only depends. Either way, it's the same. Just because I have more clutter here with the land.
Okay.
That's why I'm choosing to do it on this one, because I have more empty space and it's less distracting for my eyes.
Okay.
So I have my pencil on Ship Rock. Then I'm going to put my focal point on the line and kind of pivot this triangle.
Longitude line.
She didn't.
Yes, it's a longitude line, just trust me.
Finding that the focal point and 061. So I keep rotating. I found 061, but now my focal point is off, so I'll adjust the focal point, adjust 061, and you kind of fine tune that. And then now you have kind of all of those 3 points.
Show the 061.
Here's 060, here's 070. So 061 is right here.
Lining up with the
this vertical line.
Vertical.
So I have the focal point on the vertical, 061, and the Ship's Rock. Okay, now let's do a practice. Did you get that one, Patrick?
Working on it, but go ahead.
Okay. From long point, let's plot a bearing of 045 from long point. So I'm going to put my pencil on long point. I'm going to do it this way again so it's clearer. So I'm going to put my focal point on the line and 045. And then I can draw my line. Did you guys try that one?
Show me 0, 4, 5 on the triangle.
Here's 0, 4, 0. Here's 0, 5, 0. So 0, 4, 5 is right in the middle. All right, how you guys doing?
And what you do with the 045?
Then you could draw 0, 4, 5 bearing line. It's just a practice. Another practice with a triangle. What is the course of this ferry route? Try that with the triangle. We're going to put our focal point over the line and read what the compass says. So I have 0, 4, 3 and 2, 2, 3. All right, cool. All right, let's give this next one, we are going to be doing a ranges, so distances. So I'm going to use compass. So if you have a compass where you could stick out the pencil end for the pointy end, that way you're not etching an arc through the table that you're sitting on or something. I'd recommend using the pencil. Okay, how are we going to move this?
Do we get our true course for question 3?
No, I skipped through course because I had some updated versions and some non-updated versions in different numbers. So it'll be the same on the video tutorial. I'm going to update it on Google Classroom tonight.
Gotcha. So we're on to 4.
So we're on to 4. Let's see, we have this area. Okay. Let's see if we can move that guy. There we go. Okay, so we're on to 4. 4 tells us we don't have any bearings on this one. We have 2 ranges. So at 9:45, oil platform EVA, which is right here, measures a range of 3.9 nautical miles. And then buoy LB, right here, has a range of 3.5 nautical miles. The depth sounder reads a little over 100 feet at the time. What is your position? So we have 2 ranges and a depth sounder reading. So we need to get that distance or that range on our dividers. I'm going to get 3. What's our first one? 3.9 nautical miles. Okay, so I have 3.5 nautical miles, and that is from the oil platform EVA. So I'm going to put my pointy end on oil platform EVA, and then I'm going to draw an arc. You can draw a full circle if I want, but it does go across the land. Hopefully I know I'm not on the land. But I am somewhere along that line. I don't know where with just that information. All I know is that I'm 3.9 miles away from that oil platform. Then I have another piece of information that tells me I'm 3.5 from the LB boat. 3.5 from the LB buoy. And now we can create another arc. I'm somewhere along this line. And as you can see with these ranges, we have two crosses of our LOP, where with bearings that doesn't happen, but with the arc of the range, we have two possible positions. So we have position pretty close up here to Seal Beach, and then we have one a little further out, right in the middle of our compass rose there. So there's two ways you can figure out where you are. You could, one, look out the window. Are you really close to Seal Beach? If you are, that's most likely your spot. Are you pretty far offshore? Is Point Eva north of you or south of you? Is the buoy north of you or south of you that you just took a range off of, to try to help you determine which one you are at. Second choice is use one more piece of information. In this case, they told us our depth sounder read a little over 100 feet at the time of the ranges. So what would our depth be here at the one close to Seal Beach? Remember, our soundings are in fathoms. Okay, so we have a 7, an 8, or a 7 and a 9. So I would call it about 8 fathoms. Using my scale at the bottom, 8 fathoms would be about 48 feet. That's a little shallow for my 100 feet. If I'm looking for 100 feet, or I'll look at these numbers here, I have a 17, I have a 15, 15, 17, 15, maybe about 16. So I'll look for 16 fathoms. I have about 96 feet. 17 is about 102. So about 100 feet. So this would be my position. Then I want to get the latitude and longitude. This one first. Longitude. Number 4. Longitude is 1.8 degrees. Okay. West, latitude. For this position. All right, any questions with that one? It's just enough time to do our last problem.
I have a question.
Yes.
Tell me quickly again how you make change the feet into the fathom. It's 6 feet.
6 feet per fathom, but also on the bottom of the chart on your right-hand side, there's a little scale that has feet, fathom, and meters.
Okay. And your audio keeps going out a little bit.
Sorry, how do you get the range? How would you get the range? Oh, okay.
I have to be close to my camera or close to my computer for my audio. So
Radar. Okay, thanks.
I have one other question on the chart about fathoms. What does it mean in parentheses, fathoms and feet to 11 fathoms?
okay, that's a good question. So here, this line, that blue line where it changes from blue to white, is 11 fathoms. So anything on the shallow side is going to be in fathoms and then feet. So let's see, where did we have? We had a something that looked like a 7 and a 5. I'm just picking up ones here. 8 and a 1, 5 and a 2. So these are just some examples of the fathom lines or the soundings in that blue area. So this part is in fathoms and this part is in feet. So if I was to convert that, that would be 42 plus 5. So that would be 47 feet. This would be 48 because there's 6 plus 1. So that would be 49 feet. This would be 6 times 5 is 30 plus the 2 would give us 32 feet. That's what that little soundings and feet up until 11 meters. And then once you get to the 11 fathom line, it's a solid number. It won't have that little sub.
I get it.
Trying to be more accurate in that shallow water.
Yes, it's giving you more accuracy. Where it's really deep water here, so they didn't want to do it all in feet, because then you'd have a sounding that's like 1,895 feet or something that is just uncomprehensible. Okay, let's do our last question here.
I should have paid more attention in trigonometry.
The flashback to all those old math lessons. Okay, so for the last one here, number 5, they told us at 1430, the West End light bears 190 magnetic at a range of 4 nautical miles. What is the position? Doesn't give us a course or anything. So this was given to us in magnetic, so we don't have a deviation. So we have our TVM DC. Oops, okay. We don't have deviation. We have the straight magnetic of 190. our variation is given to us on the chart at 12 degrees east. If we are going this way from C to T, we're going to be adding east, subtracting west. So we're going to add that, and we get 202. Right? Yeah, 202 degrees true. And then we have a range of 4 nautical miles. So we're going to plot that. Let's try it with our parallels this time. So here's our compass rose, and we are plotting 202. Oops. Jiggled. Okay. There's my 202 line. Let's do it with the triangle as well. Let's see, can we fit it down here? We might be able to. So I'm going to use this line. It's not a vertical meridian line, but I want to be able to touch my light. So I'm going to use, scoot this down a minute. I'm going to put my pencil on, can we see that? On west end light. And then I'm going to put my focal point on the edge of the chart, that latitude line. And I'm going to find 202.
Where's 202?
Trying to find it here. Right down, oh, sorry. 200, 210, 202. And I can see from this, my line's not going to be long enough. So we might as well just find 202 on a vertical line. Oops. And then parallel it over so we can reach further out when it crosses the light. So, give or take. And then the last part, hold on. Tells us that we are 4 miles away. So we're going to find 4 nautical miles. From west end light. And that is our 1430 position. We can get our.
I got it. So you're taking the other end of the compass and you're just going right on your heading line. Right?
Yes. I think so. Okay. Stop to share real quick. We're just about at the end of class here. So we got through assignment number 5. Assignment number 6 and 7, you don't need a chart for. It's just practicing this concept of compass, magnetic, true, deviation, variation, all those combos. So I did post the tutorial videos. So if you have questions, you can check that out or just shoot me an email, text me, whatever. And I'll be online before class tomorrow. You could, or before class next week, you could get with me there too. Other than that, next week we are going to be doing speed, distance, and time calculations, and then plotting some DR courses that way. So that's what we're doing next week. How you guys doing so far? Good pace? You're
Good.
doing all right?
You know, I was thinking how amazing it is to have these charts. Somebody did this work. I mean, without the chart, we would be lost
Yes.
at
It
sea.
has lots and lots of information on it. It's up to us to decipher that information. So,
Yeah.
cool.
Thank you, Captain.
Thanks,
Well,
Captain.
Okay.
have a
Thank
good
you.
one.
All right, gonna be lots of YouTube watching.
Bye.
Glad
Good night.
for the weekend class that you did earlier, because all this is now very easy.
Good. Good. I'm glad. Well, we'll be doing more challenging stuff.
Thanks, Bree. I'm so
Bye, Shelly.
thank God the videos that I can go over.
Oh, good. I'm glad you're using them.
Yes, thank you.
All right.
All right. Bye. See you next week.